We were on the fast blow fuses. So continuing to the last slide. So we were on the fast blow fuses. So in fast blow fuses, we have seen blade type fuses, right? In blade type fuses also we have different type of fuses like ATO fuses, mini fuses, and maxi fuses, okay, micro, low profile, mini. So these have the typical particular application, and we use in that, like ATO fuse easily replaceable for low voltage application used in most of the passenger and commercial vehicles, and their rating also comes very less. Coming to the mini fuses, use less spaces and cope with the high temperature, where you have the high temperature application and you are struggling for the spaces, then you can use the mini fuses. And for mini fuses also, this is the condition, they are used for the lesser current. Coming to the maxi fuse, the maxi fuse also comes with a time delay fuse characteristic, sometimes used for the high current, high temperature application, and it replaces the fusible links. So I have discussed the fusible link in the first one. So instead of fusible links are bulky and they use more space. Instead of using fusible links, we can use the maxi fuse, which uses less space and gives the high current application as well. Okay, coming to the second one, our not second one, then we will see some blade type fuses time characteristic. So as of now, you just forget about this column. So percentage of rating we will see, and opening time minimum and maximum. So what does it mean? That suppose 10 ampere of current is to be flown that particular wire, okay, but if you are flowing the 100% of current, matlab 100% matlab 10 ampere in this wire, then and you are using that particular fuse, okay, then the opening time would be this much, okay, this many seconds opening time of that particular fuse. If you are if you are increasing this particular current by 1.35 times, then this particular fuse will blown into the 350 millisecond or 600 seconds, okay. Then for 200%, then 100 millisecond or 5 second. So this is like 600% rating, then 100 millisecond and 150 millisecond. So these are the for ATO fuse, these are the for mini fuse, you can see here. So generally we take this one, okay, 135%, 0.15, 0.080 second. And if you see that as the current is increasing, percentage of rating, then this blown time is reducing, okay. The percentage of rating for the maxi fuse also, the opening time, and this is the rating. From this curve also you can see that percentage of rated current, okay, if it is 200%, this is the trip time in the second. Trip time is nothing but that how much fast it is going to be blown. So if it is, you see, if it is 600%, then it will blown in the you know percentage of rating current, it will blown immediately. If it is 200%, 400%, okay, it is one. Then if it is less, like 150, then and 100, it will take more time, okay. This is the graph of the time versus trip time in second versus percentage of rated current, okay. So as this rating current is increases, then our fuse will blown immediately. Because of this, the concept of fuse blown is I square T, okay. If I will increase, and duration will also increase, duration, in which duration it gone, then this time of opening the fuse will reduce, okay. We will understand this particular concept more in the coming slides, okay. what is this rating and all those things. So coming to the second, that is slow blow fuse. So slow blow fuse, as we have earlier discussed, slow blow fuse can allow the peak current to pass for the some duration without blowing it, and it is designed to blow on sustained load for higher duration, allows temporary inrush current to pass without opening, and it is so designed to sustain overload and the short circuits. So in this slow blow fuse, we have seen how many fuses were there. Cartridge fuse were there and bolt down fuse were there. In cartridge, J case is there, then low profile is there, and bolt down fuse we have the bolt down. Sorry, bolt down we have the MIDI fuse and then mega fuse. Okay. So cartridge fuse JKs provides the both increased time delay and low voltage drop to protect the higher current in cartridge fuses. Low profile JKs lower overall high sorry high reduction allows for height reduction allows for more space and weight saving. So their size, okay, the compact size, okay, based on this these are defined. So here also if you see the percentage of rating and the opening time of the fuses. Okay, so someone if ask you one question that tell me the how much time it will take for fuse to blown. Okay, so how you will respond this question. You cannot say that this much second. Okay, it depends on how much percentage of rating you are the current is flowing in that particular fuse. Okay, so suppose if 10 ampere of fuse is there, okay, and if your 10 ampere of current is flowing, then it will take this much seconds. But if you are your current is 135% is flowing in that, then it will flow in this second. If it is 200 percent of rating, then 4 seconds. If it is 350, then it means this much. Achha, one thing you notice in this, that when we are going from fast blow to slow blow fuse, so this particular seconds are increasing. Can you see here? So I take one example. I take one example of this one. 130% of this. Okay. So how much? 60 second and 100, 1800 second is the maximum. Okay. Then we will see the slow blow fuse. Sorry, fast blow fuse. So 130% if you see 0.75 and 600 seconds. Can you see this? Here it is 0.5 second and here it is 60 seconds. So I told you one thing, fast blow fuse will blown immediately. What does it mean? Like if my 0.5 second it is blowing, but when it comes to slow blow fuse, for the same rating it is taking 60 seconds. I hope you got my point. What does it mean fast blow fuse and slow blow fuse from this time characteristic? Am I clear? If it is not clear still, then you can comment below of this video and I will try to give you the answer of this question more precisely. Coming to the bolt down fuse, and bolt down fuse comes under the slow blow fuse. Okay, sorry, slow blow fuse. This is slow blow fuse or time delay fuse. So in this also we have the MIDI and one is mega. Okay, so MIDI bolt down fuse are say space saving MIDI fuses, protect high current wiring, available with ampere rating of 30 amps to 200 amps. Okay, as I told you, these slow blow fuse comes most of the time on higher current. And why higher current? I told you that peak current goes on higher, then it sustains. So that's why most of the time they comes in the higher currents. So someone suppose ask you one question, where what are the application or what are the devices where slow blow fuse will be used? So I told you, when you have the inductive load, okay, when you have the capacitive load, in those conditions you have to use the slow blow fuse. So this is the material only, tin plated copper terminals, applications, car, SUV, truck, buses, off-road vehicles. And here is your MIDI fuse, 80 amps, 150 amps, 200 amps. So here this is casing, I will show you. These are the bolt down also we call it like this. And sometimes we have the clear spacing also. Sometimes it is, not the clear spacing. Here is the specification. So tin plated copper, and this is the most important, mounting torque for this 4.5 and 6.5 Newton meter. So what does it mean? Mechanically, when you are putting this particular fuse in your vehicle and you are not giving the particular torque, then what will happen? That this particular thing will be loose, and if it is loose, then there would be a vibration. If vibration would be there, there is a chance of ignition or arcs. Sorry, there is a chances of arcs. Okay, so that's why we have to, when you are using this particular, then you have to take care of all these things also. You will see all these things in the field issues. Okay, I will come with the this particular video also, how you have to resolve the field issues, where it comes, and what are the. So there were some situation where your fuse is blowing, but it is under the specific specification or load, but still it is blowing. So there would be some mechanical region, and this is the one mechanical region where you are not giving the proper torque on the bolts, and it is having loose, and due to loose there is a vibration, and due to those vibration it creating arcs, and arcs if it is creating, then your fuse will be blown. Okay, if you see the fuse blown, how fuse is blown, if you see, uh, so the fuse blown reason is heating, and how heating is, there are two three reasons of heating. How it can be happen? First thing, that your current is higher. Okay, second thing, that you have the loose connections or loose fitment, and due to that arcs are creating or heating is happening, and due to that your fuse will be blown. Okay, so we will see all these, but you have to take care this thing also when you are diagnosis your fuses in the field issues. Coming to the mega bolt down fuse, so as we told, this is the last fuse which is in slow blow fuse, high current circuit, protection up to 250 amps, even 500 amps we use this. Okay, ideal for battery and alternator protection, and starter or other heavy gauge cable require ultra high current protection. So somewhere the peaks would be more. Okay, and your wire gauge of course would be more than 16 mm square, 30 mm square. So on those conditions, battery alternators, in those conditions you have to use the mega fuse. So you can see here, this is clear top housing fuse, this one. Okay, so moving to the last one, that is very important. All these we have seen. Okay, what type of fuse, what is the fuse? Okay, we have seen all these particular thing, but how you select the fuse? Okay, so I have taken one example in earlier also, that you have the headlamp of 60 watt. Okay, then what is the continuous current we got? 5 amps continuous current or normal operating current. You can see the last video where I have calculated this current. This is nothing but P is equals to VI. Okay, now first question, the fuse selection, how it happens. So continuous current in fuse must always be less than 80% of its rating. Okay, so it varies from company to company. So few take 75, 70 or 80, but you, as of now, you remember just 80% of its rating should be less than. Or what you can say, fuse rating will be 125% of the continuous current. Both statements are same. Okay, you can do in any way. Okay, so suppose my current is continuous current is 5 amps. So suppose my current is continuous current is 5 amps, then fuse rating what will be? I have shown 125% of continuous current. Okay, so 125 divided by 100 into what is my continuous current? 5 amps. Okay, so can I write like this? 1.25 factor can I put is like this? Then 5, sorry. So we are not doing 5 fives 25 to 5 to the 12 1, and this is 5 into 6.25. Okay, this is the fuse rating should be. But you know that fuse comes in previous slides we have seen, fuse does not come in point or something. They generally comes in this form: 5 amps, 7.5 amps, 10 amps, 15 amps, 20 amps, 25 amps. Like this generally they come. So if your current is fuse rating is current coming to 6.25, then you have to take the next fuse like 7.5 amps. If 7.5 is also not there, then you can go with the 10 amps. Sometimes the people don't use this 7.5, then you can go with the 10 amps of fuse. So I hope you understand that how we select the fuses. Okay. So suppose any example you can take. Suppose 100 watt of system you have. Okay. So 100 watt of system. What is P is equals to VI? 100 divided by 12. This would be my current. So I would be, so I take it 8.4 something I take. Okay, continuous current 8.4 something it will come. Okay, so this current will come 8 point something, then fuse rating you have to do. So 1.25 into 8. How much it is coming? 10. Okay, but I have not taken this point, so it will come something like 10 point or 11 point something. Okay, so after 11 how much fuse rating it should come? We have seen here, if fuse rating is coming 6.2, we have gone with the 7.5 or 10. If our 11 point something is coming fuse rating calculation, then we will go with the 15 amps. Okay, so this is the first condition how you have to go with the. Is this the only condition which we have to consider? No. Why we consider only 80% of its rating? So I'll just tell you the one reason: the 10% of derating for higher temperature, because we know the fuses are operated on the higher temperature, not the ambient temperature. 10% of derating we have taken for the aging phenomena of the fuse element, where we have this fuse element which is made some metals, and over the period of time there would be aging effect. Because of that we have taken 20% less the 80% of its rate. So there can be two possible cases: fuse always melts before the wire is damaged. Okay, So as I told you, fuse is nothing but which protects the wire. So if your wire is protecting always and fuse is always melting before that, that is 100% protection, and fuse always melt after the wire is damaged, then no protection, then there is no use of fuse, you are selecting the wrong fuse. So this is one factor which we have used for fuse selection. I will show you the other factors which we have to take into the consideration, and then we will come into some of the essential factors which we need to consider in the fuse selection. So factors in the selection of the fuse. So first is the normal operating current. Normal operating current is nothing but the continuous current, which we have seen many times. 5 amps in this case, and this case in 100 watts, we have seen 8 point something. Okay. What is the operating? Whether you are working on 12 volt or 48 volt. Okay. So as I told you that P is equals to P is equals to VI. So your voltage will be different in 12 volt and current will also different. Okay. Continuous current. Is this AC circuit or DC circuit? Ambient temperature, this plays very critical role. I will show you how we have to see this particular ambient temperature and how we have to take into the consideration. What is the available short circuit current? Okay, so short circuit current nothing but when you don't have the mm, any resistance, you are just you have the battery. Okay, you have the positive terminal, you have the negative terminal, and because of something your your tool get touched to the positive to a negative, and this is called short circuit current. Okay. So in this case, like it comes very high current. Okay, you can calculate uh, by generally P is equals to VI, you can calculate, and it comes around a moment. Sorry. Sorry, sorry guys. Just give me a moment. So see, if you are calculating any short circuit current, how you will calculate? The formula is same, ISC. So V is equals to IR. Okay, and V is your suppose 12 volt. Here the your I into R. R, what would be the R would be very less. Okay. So suppose 12 point and I take R is equals to 0.05. Then this will come around 2400 2400 ampere of short circuit currents. So this also plays very critical role when you are selecting the maximum allowable I square T. So I square T is responsible for your melting the fuse, and it plays very important role. Coming to the inrush current, which I told you, are there in inrush current available in the system or not? Inrush current is nothing but peak current, transient current, which I have told you, and in what type of load it can be: inductive load and capacitive load. Is the protective device being used for circuit protection, so overload? What is the physical size of limitation? So we have seen different type of fuses where we have the different profile. In blade fuse you have seen 6 type of profile, and in others you have seen other types of, like bolt down mein, in bolt down we have seen midi, mega, all these types of. Is this PCB mount or through hole? Does fuse need to be filled replaceable? We have to see whether it is serviceable or not. Is the resistibility an issue? What is the safety agency approval are needed, like ISO standards? Okay. How will I mount the device, and what are the cost consideration? So all these factors we have to consider when fuse we are selecting. But when you are going for some interview and you are doing your 2 days work and you don't want to go in all these things, because this is something when you are doing the concept of your power distribution, you have to consider all these points when you are doing from your scratch. Okay, but as you are a technician, you are a layman, and you just want to understand that what type of fuse I have to use for this particular load if fuse is blown. Okay, so you have to do just fuse the main point you have to remember in selecting 125% of the continuous current. Is there any peak current in the circuit? If there is any peak current of the circuit, then I have to use the slow blow fuse. I have told you this thing many times. Wire gauge to be considered when you select the fuse. So wire gauge, as I told you, like suppose your wire gauge is for 4 ampere and you are passing 6 ampere of current, then and your suppose there is a 0.13 square. I will explain this thing in wire selection in details, what how these particular CSA cross section area of that particular wire to be selected. But as of now you understand like that कि for 4 ampere 0.13 square of wire is sufficient, but for you are you know for 4 ampere, sorry, for 4 ampere you have used the 5 ampere of the fuse, or 7.5 ampere of the fuse, 7.5 ampere of the fuse. But you are carrying the current in this particular wire 0.13 6 ampere of 6 ampere of current you are passing through this wire. Okay, but your wire CSC was designed for 0.13. Okay, what does it mean? That this particular wire, if you are carrying this particular current for long durations, then it will create the heating effect. Okay, so it doesn't matter 7.5 you have used, because your current is 6 ampere, which is lesser than 7.5 ampere of fuse rated, which is lesser than your fuse value, and it will pass through your wire and it will start heating your wire. Your fuse will not blown, but your wire will be damaged. You got my point, what I'm trying to say here? Okay, if still it is not, you are not getting, then you please put the comment below. I will explain again. Okay, so 4 ampere of wire, 4 ampere of current is passing through 0.13 square Okay, this is the wire side, but you are passing 6 ampere of current in 0.13 ampere. Here you have used 7.5 ampere of fuse, 7.5 ampere of fuse. Okay, but this wire side is getting heated due to this 6 ampere of current. Your fuse will not blown in this condition because your current is lesser than 7.5 ampere, but your wire will be damaged due to heating effect. So in this case, when your 6 ampere of current is passing, then you have to increase the wire gauge. Okay, you have to consider all these things, or due to the peak currents. Okay, coming to the, if there is a unknown load like accessory power socket, then you have to give the 100% protection. So 100% protection is nothing but that you have to give the rating which we have discussed, 125 of the continuous current, and you have to give the note on higher side. Okay, like 7.5 is coming, then 7.5 you should not go with the 10 because there is a chances then he put the unknown load and it takes it draws higher current and your wire will be blown, damaged. Fuse always protects the wire, not the device. You have to remember this. Ambient temperature plays very critical role. We will see in the coming slide how this ambient temperature will affect your fuse rating. So these are the points